The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons.
Hello everyone and welcome to the .NET Core podcast, an award-winning podcast where we reach into the core of the .NET technology stack and, with the help of the .NET community, present you with the information that you need in order to grok the many moving parts of one of the biggest cross-platform multi-application frameworks on the planet. I am your host, Jamie Taylor, and in this episode, I talked with Davide Bedin about Dapr, the distributed application runtime, how you can leverage it to manage your microservice-based application stacks regardless of the technology used, and his most recent book, Practical Microservices with Dapr and .NET. I'll let Davide explain it in a moment, but Dapr, D-A-P-R, is different from the ORM called Dapper, D-A-P-P-E-R. But of course, if you're on the Dapr, D-A-P-P-E-R team, feel free to reach out at the contact page, .NETCore.show/contact, because I'd love to do an episode with you. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. So thank you ever so much, David. Just to set that correctly from the start, it is David, isn't it, or is it?
Yeah. So it's Davide, but David is fine. So it's fine. Okay.
We'll do it correctly. So Davide, thank you ever so much for spending some time with me this afternoon, and I really, really appreciate it because you're a very busy gentleman, and thank you ever so much.
Thank you very much for inviting me. I'm really happy to be here and talk with you.
Thank you ever so much. So we're going to be talking today a little bit about Dapr and a little bit about the book that you have on Dapr and .NET. But a couple of things we need to clear up just real quick first is that there are two different things, Dapr, D-A-P-P-E-R, and Dapr, D-A-P-R. And we're going to be talking about the latter, DAPR, rather than the ORM system, right?
Yeah, exactly. And by the way, I also, in over my experience, I had the chance to work with Dapper, the ORM. I probably spent more time on this than, for example, Entity Framework, for what it's worth. And so, yes, Dapper, short with the APR, is the distributed application runtime, which I'm most passionate about it, and on which I'm really focusing since the last year.
Sure, excellent. So I guess before we continue on talking about Dapr and your work with Dapr, I was wondering, could you let the listeners know a little bit about you? For instance, I know they may know from the description that you work at Microsoft.
Yeah.
And good. Obviously we'll put the caveat in that you are speaking for yourself, not
Absolutely.
for Microsoft, right?
Absolutely. Yeah, thank you. So, in fact, let's start with the presentation. So, I'm Davide Bedin. I'm from the beautiful northeast of Italy. So, if you picture me, I'm halfway between Venice and the Dolomites. And I currently am a cloud solution architect at Microsoft. So, cloud solution architect nowadays is a common role. But for those who doesn't know what a cloud solution architect does, is I work with enterprise customers to help them use the cloud, Azure from Microsoft, in the best, most effective possible way. And I have been a cloud solution architect in Microsoft for the past 7.5 years. And before that, I was an independent software vendor, an ISV. And this is the experience from which I have my development background. And I was in the retail software management system sector And so I always combine the experience as being a customer first of Azure and Microsoft .NET and everything else. And then I became an advocate from the Microsoft side. So I'm sure that the way that I saw Dapr and how enthusiastic I am, it comes from really both experiences. What I wanted to have a long time ago when I was a developer, and what I see now as a cloud solution architect that can solve many, if not most, of my customer issues.
That's the great thing about these tools, is that we discover them and then we go, oh, if only I had this tool 5 years ago, 10 years ago.
Yeah, and probably is something that tells a lot about our age, I suppose.
Oh, definitely. Okay, and so before we go on to a little bit more about Dapper, let's talk about the book that you've written as well, because full disclosure, I've had a chance to read the book, and I knew nothing about Dapper going into the book, and I feel there's more than enough information there for me to actually start using it with a real world application.
I'm glad to hear that. So we're probably at 1 year from when I started working on the book. So Dapper, and for the rest of this podcast, we'll say Dapper, but it's a distributed application runtime. Has been something on my radar for far more than the last year. So because it's a project that started probably 1.5 years or a little more. And I follow it also with some colleagues. We try to build something. During the lockdown, you had more time to study. And so I took the chance to learn more about Dapper. And I, with my colleagues, I published a series of articles on LinkedIn on our learning process of Dapper. And from that starting point, the Pact, the publishing company, contacted me asking if I wanted to write a book on Dapper. And so obviously these are the kind of opportunities you have to take. Mm-hmm. And I never thought of writing a book. And I'm really glad that so many people are reading it and find it useful. And since the publishing of the book last December, I have been doing a lot of conferences because I really wanted to spread the knowledge and my enthusiasm for Dapper.
Excellent. So just so that the listeners are aware, what was the title of the book? Sorry?
Yeah, absolutely. It is Practical Microservices with Dapper and .NET.
Excellent. Like I say, I've read through it. We had a pre-interview call a few weeks back, and I showed you that I have lots and lots of tabs stored in the book. I like to do that because with a book like that and with other technical books, there's almost always something really useful on every page, right? But what I like to do is I like to put a tab on an incredibly useful, this is a great point, or this is a command I should learn, or this is an important thing about the theory behind how this system, this technology is working. So yeah, I've like I said, I've read the book myself, which is going to come across a bit weird because I'm going to be asking you in that instance some leading questions. But that's how we do things. So so yeah, like we've said earlier on, this is for Dapr, DAPR, the Distributed Application Runtime, not Dapr, DAPPER, the RM. I mean, they're both very, very useful, right? Like you said earlier on, you started out using Dapr, DAPPER rather than entity framework, and that's totally fine. But that's not the subject of the of today's interview. So I know that. So I know from reading the book that I can use Dapper to sort of manage my application stack, right? If I have a bunch of microservices, I can throw Dapper at it. It does some magic, and it's good to go, right? Is that how you would describe it? How would you describe Dapper itself?
I agree with your point of view. So in general, Dapper offers a set of building blocks. There are 7 building blocks right now, and these building blocks are the outcome of a long and vast experiences by Microsoft in developing and operating massive hyperscale distributed solutions, and also helping customers achieve the same. So from all these experiences and best practices come out, and they with Dapper they are manifested as the building block. So you have a building block if you need to manage the state in your service, or if you need to establish a communication between one microservice and another, or implement other patterns. So the idea behind Dapper, and what I verified as a need from my perspective as a cloud solution architect, is that enterprise developers should focus mostly on the business logic, on the real value they are adding into code. They should avoid being slowed down by the complexity of a framework, by managing the dependencies of libraries that will be used for the plumbing code in order to connect your code to discovery mechanism for services, or a library for managing a record on a database, or the library to send a message with a specific messages system, this kind of stuff. So this is the kind of scenario that I suppose we all share. So I at least I had it. It has been my ongoing pain in my previous experience, that the more your system gets complex or evolves, if you're lucky enough to build a solution that lives long enough, you will have a burden in keeping track of the dependencies you have, and more you will also might need to combine different contributions by different members of your organization or teams that might use also other languages, because I approached the description of what Dapper is in my book from the .NET perspective, but Dapper is a runtime for any language. So it's really about, this is the perspective that Dapper has originated from, and the goal that it has to achieve, it wants to achieve.
Sure. I mean, I agree with you completely in that, regardless of where you are in that stack of building applications, the thing that you should be focusing on is the building of the application, right? Not necessarily the wiring together of all the services. Whilst that is very important, when you have a bug, it's usually not in how the services are wired together. It's in the code somewhere, right? And giving that power back to the developers to actually wire everything, to build their blocks of functionality and allowing a system to step in and wire it all together, I think is absolutely wonderful.
Yeah, I agree. So if I can give you an example of something I consistently faced over my career. So I'm really passionate also about, for example, Azure Service Bus. Okay, so it's really probably my favorite Azure service. And it has been instrumental in all the work I did in my all the solution I built. And but it's a library that you have to carry around with your project. And once you have many services, which will happen if your aim is to adopt an architecture such as with microservices, you will have many components, each of these using the Azure Service Bus library. And obviously you will tend to think that you have a specific way of using Service Bus or any other messaging system. And so what I did was let's build some common practice that applies to our scenario in the way we deal with this or that feature of Service Bus. And over time, we had to maintain also this part of the code. But really, when you see, when I see things in the past from now, I think that in most, if not all the scenarios, I could have used the default approach and maybe just configure some settings in, for example, the locking or how the session was handled. But I was not adding as much value as I thought. I was trying to solve a dependency, not problem, but a dependency burden by adding more complexity. So when you use Dapr, everything lives, everything. The publish and subscribe building block, for example, gives you the ability to send messages to other parties, other microservices you are not aware of in the operation, and to be invoked whenever an event, a message from the same publish and subscribe gets notified to you, because your code expressed to Dapper the interest for these topics. And so everything boils down to Dapper, which lives in a sidecar. So you can think of it as a process that is running side by side with your application. It will be this sidecar to use the library for Service Bus, and what it will do, it will invoke a method on your microservice to notify you that something happened, an event, a message has been received, and asking you to process it. And then you reply with a success. You also can say, hey, I'm not able to process it right now, please retry. Or you can also fail if this is the case. And all of this will influence the rest of your workflow. But you will not have the need to take care of the specifics of the library and the system you are using. Okay, so in a sense, also, if you have a situation in which you are confident that you need to control directly the way you consume or send messages and events to any messaging system, you can and you should continue to do so. But for most of the scenarios, and I think you can benefit far more from a large community that is working together on a very good starting point with the publish and subscribe building block and focus on the business logic. Because probably if you are an enterprise developer, your core business is not in the plumbing code. It is in solving problems with code.
Absolutely agree with you. It's like you said, your paycheck doesn't necessarily come from, there's a problem with service bus. Your paycheck comes from, is this customer able to reserve and purchase this item, for instance?
Yeah, and also to build on top of this, it is that probably the way that the publish and subscribe leverages Azure Service Bus and Event Hub, RabbitMQ, MQTT, all the other components, it probably is the best approach, unless you have completely different scenarios. So this is best practices getting into code. And so I see a lot of value in leveraging this approach with sidecars.
Sure. And so Dapr takes care of that, doesn't it, by using, it's Kubernetes, isn't it?
Well, so you have different options. So okay. Dapr, the runtime, can operate in a self-hosted mode and Kubernetes mode. So with self-service, which is the one you will probably face first, because if you install Dapr, the command line interface, the tooling, in your development machine, you will see Dapr running in a self-hosted way. But there are some scenarios in which you might want to use Dapr on a group of virtual machines or nodes, generally speaking. The other, and this will also be self-hosted, okay? So the other deployment mode is with Kubernetes. So in this case, Dapr builds upon this very popular orchestrator for compute resources, and is the way that Dapr gains its also portability, because Dapr can work on any Kubernetes cluster that is CNCF, Cloud Native Computing Foundation compliant. So Microsoft Azure, your on-premise environment, and any other cloud vendor. Okay, so this is one of the aspects that gives Dapr this strong advantage on portability. And when you install it on Dapr, you will see that in Kubernetes you will have four, if I correctly remember, Kubernetes services that will help distribute the configuration of the component that you choose to use. So maybe on premise you might use RabbitMQ for the component for publish and subscribe, but once you are in Kubernetes on Azure, you will use Azure Service Bus. This is just a change of configuration. and it will be one of the 4 services that Dapper has in Kubernetes that will let all the microservices know of this configuration and how to apply it, and also takes care of many other aspects. But yes, these are the 2, so Kubernetes and self-hosted.
That was going to be my next question. Was obviously, this is Dapper is something that was being developed in the open, and there is a community of developers around it. Mm-hmm. But obviously, one of the groups, shall we say, that is helping to push the development of Dapper is obviously Microsoft. And obviously, some people will be saying, "Oh, well, can I use that with my Amazon cluster or with my Google cluster or, my Linode or whomever?" And you just answered that straight away. So I don't have to ask that question again.
No. Well, there is one more aspect to this part. Is maybe not on the features of Dapper, but the way that the project is moving forward. So there are, if you want to know more about Dapper, there are community calls every 2 or something like that weeks, in which the team and the contributor explain what they are working on, and you see. If you look at one of the last calls, you see how much time is there is someone from outside of Microsoft talking about the new feature they're working on, or really the new features that already have been published. So the community is really, really important and really active. But more on that is that the adoption process of Dapper to the Cloud Native Computing Foundation has been started. So that's the also something really important, and it's part of the importance that Microsoft sees in contributing to the open source communities.
Sure. And I think that's it's a topic for another day, I think. But there's a great push from Microsoft to be, hey, let's build things for other people to use, and it doesn't matter whether they come to Azure or whether they go to AWS or whether they host internally or whatever. Let's just build some great tools for people, right?
Yeah. It's the focus is really on developers, and developers must be able to move wherever they want, depending on situation they cannot think in advance. So let's build tools that help them face these challenges.
Oh, absolutely. I mean, I don't know whether you've been on many projects where the requirements have changed very suddenly, but I can totally understand. It's happened to me quite a few times.
Yeah, I think so. Yeah, also to me.
Okay, so we've talked a lot about .NET and .NET developers, and obviously this is a .NET focused podcast, but is Dapper specifically a .NET technology? Like, if I had a service that was, say, in Node.js or Go or something like that, can I still use Dapper to sort of wire everything up? Does it work like that?
Absolutely. Well, Dapper has been developed and is being developed in Go. Okay.
Oh, okay.
So, but what you see, and so it will be relevant if you want to, for example, contribute with a new component, okay, or you want to contribute to a feature set. So you have to know Go, okay. But for the developer point of view, which is always my point of view, so it's like I'm an enterprise developer. So I relate myself, my code, to Dapper via API. So Obviously, my book is focused and starts with .NET because it's my background. Okay, and so I feel far more comfortable in working against .NET SDK that helps me bridge my choice on C# and .NET to the technology, the runtime I'm using, so Dapper. But also over the book, and it's something that I strongly suggest to anyone that is approaching Dapper, start looking at Dapper from the API perspective. Then, once you understood how does it work, and really how easy and simple is the structure of the API, they're really easy to understand and to see the concept behind it. So once you have this knowledge, then you can use the API directly from your code if you do not want to use another SDK. But as I said, from .NET, it has been really helpful to have a .NET SDK for Dapper, and there are SDKs for all the languages. You mentioned Node.js, absolutely, Python, so Go, absolutely, Java. So there are SDKs for rich SDKs for all of these languages. But there might be also situations in which you might prefer to interact with Dapper directly with the API. So it's really any language. You can use any language with Dapper, even the ones that do not exist yet, because they will be able, quite probably, they will be able to invoke a REST API, right? Mm-hmm. So in that sense, yes, it's any language, and .NET is the starting point for my book.
Excellent. I do prefer it when it's to a certain extent technology agnostic.
Yeah.
Because, like you say, it then doesn't matter. If you have a component, let's say you're building something that does analytics on some retail data, right? Mm-hmm. You may want to do some machine learning things with it, at which point Python might be the best way to do that. It may not be. And so you can wrap your Python code into a service, into a microservice, attach that to your Dapper provided application stack, and guess what? It just works, right?
Yeah, absolutely. And I relate to the experience you described, because it's something I went through many times. So situations in which once you're not anymore the only one deciding or influencing the language that your shop, your organization is using, and so in my case was C#, you realize that the world is much larger, and there are larger organizations in which different skills come together, and there might be languages that are far more popular in the community from which those skills are coming. For example, Python, that you want to embrace, and but not only enabling them to use Dapper, but making them equal first class citizen, or equal citizens, even more. So they can use logic that might have been built with C#. And the same applies in the other way.
Sure. And like I say, I really like that, because, I mean, again, I've been on projects before where there's this binary blob which is in another language, and nobody knows how to change it. And, when there's perhaps an operating system update, oh, we can't update the server. This was years and years ago. but we can't update the server or the runtime because we don't know whether it's going to affect the binary that exists. Maybe it was in Java, maybe it was in Python or some other language, and it sounds like Dapr could help with that.
Yeah, absolutely. It makes far more easy to define your architecture as you need it. So the fact that you might need to have another microservice, with Dapr you will avoid the initial tax on. Yes, but where it comes, where are from the libraries, the practices that I have to use to start, where are they located, what template I'm going to use, and if a new microservice comes with another different need that shift the language or the libraries or the components that have to be used. So, for example, they have to react to events coming from a Kafka stream. Okay, you will not have the complexity in getting started, because Dapr simplifies the adoption also of a microservice architecture.
Sure. So one of the things that I know about because we were talking a little bit about microservices, right? Mm-hmm. One of the things that I know about when I was reading up about Dapr and after reading your book was there's a separate thing from Microsoft called Project Tie, right? Mm-hmm. And I'm thinking, hey, Project Tie helps me manage my microservices too. Is there some kind of crossover between them, or are they completely separate projects? How do they fit together?
They are separate projects. So if I remember correctly, Project I is a .NET Foundation project, and from my perspective, so in the context of the book, so Tie has been an additional tool that I could leverage for the part of my book that evolves around debugging. So I described how you could use VS Code by changing the configuration and having to specify different ports for each of your microservice, because if you wanted to run everything locally, you have to avoid port overlapping. And so an additional way of dealing with this complexity maybe in VS Code locally has been by adopting Tie. So I used Tie for far less than it is capable of. Okay, and so there is a recipe of Tie for Dapr. You just specify in the configuration and Tie configuration file the projects that you want to start, and it takes care of everything. But yeah, Tie is much more than that. But in the context of the book, I only took a look at it from this perspective.
Sure, and I think that's to be expected, right? If there's another project that you can use, you can leverage to help you with debugging, you're gonna take a look at it. What I really like about Tie, Dapr, you mentioned it earlier, VS Code, is all of these tools and frameworks and technologies that are coming out now, not just from Microsoft, but from a lot of other providers. They're all completely free, right? Mm-hmm. Yeah. And you said yourself, hey, 5 years ago, 10 years ago, I'd have loved to be able to use this.
Absolutely.
And 5 years ago, 10 years ago, it would have maybe cost you thousands of dollars to get something like this.
yeah, absolutely. And this is we are late on this level. And also what I saw with VS Code, which could, you could have a series of podcasts on VS Code. To me, as cloud solution architect, VS Code has been the lingua franca because all of my customers, whether they use Java or C# or Python, or on Windows or on Mac, they all use VS Code. So you have a common experience, and really, it's incredible what VS Code has been capable of achieving.
Oh, absolutely. I tend to, when I'm doing purely .NET things, I tend to live inside of Rider from JetBrains. But when I'm doing absolutely anything else, if I have a number of services, and maybe there's a UI and a couple of APIs and maybe some Python things or whatever, and a Docker thing, that's Visual Studio Code, right? That's where I live when I'm doing stuff like that. And it is, as you say, it's absolutely amazing. Just the things that it can do, the extensibility, it's absolutely fantastic, I have to say.
I completely agree. Even if it seems like I'm taking the compliment, but it's Microsoft. I have nothing to do with VS Code. I really look at it from the perspective of a customer. Really,
sure.
It's really good.
So you mentioned earlier on, one of the examples you gave was the pub sub stuff, publisher subscriber things with a queue. And now I happen to know, because like I say, I've read the book, right? I happen to know that you can do direct service to service invocation, and you can obviously do publish subscribe, right? And this does feel like it's a leading question. Would you use one over the other, or is it because it feels like that's two different technologies you could use in slightly different ways, right?
Yeah, absolutely. They are different, and they solve different needs. So, other than from the technology perspective, I think that choosing if you want to directly invoke another service, or if you want to send a message to another service with the acknowledgement that the other service will process it and therefore do something else, reply to you, continue the processing, whatever. It's best. It's a decision that has to be made from the architectural point of view. So, if you usually when you first start thinking about your solution architecture and you compose it with as many microservices you think are needed, you probably are describing a relationship between the microservices that can translate to a service-to-service invocation. So what you do with Dapr is your code with the help of an SDK or by directly calling the sidecar API of Dapr. It will, for example, post a JSON payload to another service which has a specific name, and you want to invoke a specific method of that service. And you don't have to care about anything else. It will be Dapr to discover where in your environment, whether it is a group of VMs or a Kubernetes environment, it will be Dapr to discover that it has to reach this or that Kubernetes service, because there it's the place where the destination, the counterpart microservice is placed, is currently running. Okay, but you have this need because you want to have immediate feedback of the exchange that you are doing with the other microservice. Let's see it this way. So you have something that it might be too complex to orchestrate if you add the publish and subscribe because you have the need to send a feedback to a user, let's say. Well, maybe in that scenario you could leverage the service-to-service invocation for one part of your interaction and leave it to publish and subscribe for the rest. But also I see that publish and subscribe is much more powerful than this, other than just simply postponing the process, which is absolutely great. And most of the issues in a solution architecture might come from the fact that queues has not been used as much as they could. But with publish and subscribe, one of the great benefit comes from the ability of sending a message to an audience of other counterparts, other microservices that you do not know in advance. So it gives you benefit over time, if you have to integrate many more microservices that will be added over time to your overall solution, well, if they can have this kind of relationship with, so mainly absolutely asynchronous with publish and subscribe, then they just need to subscribe to a topic, knowing that you, as the source of the messages for this topic, you will continue to send it, and it will be Dapper responsibility to manage the subscription, because every messaging system has its own mechanism for creating what we commonly name as topic and subscriptions. So it could be, going back to the initial question, it could be the need for a direct interaction or the ability to add to have two components work at different paces, at different frequency, and also to interact with a known or unknown audience that will drive whether you prefer service-to-service invocation or publish and subscribe. But as with any other building blocks of Dapper, you don't have to choose. So you just use the feature, and you can have your microservices being able to receive a direct invocation as well as be invoked by Dapper in reaction to a message coming into the subscription. So you can even make your services, microservices, capable of dealing with both of these scenarios.
I genuinely like that because, like I've hinted at a few times, some project will invariably the requirements of a project, will invariably change over time. And you may find that, yes, we've gone with direct service-to-service invocation, and then, some new requirement comes along and you're like, oh, wouldn't it be so much easier if I can just place this on a queue and deal with it later?
Yeah, absolutely. Absolutely. Yeah, I have probably a bias, a favorable bias toward publish and subscribe. Mm-hmm. And so, in fact, in my book, soon the sample becomes heavily focused on publish and subscribe. Because it's the one that I relied upon the most, but also in my experience as developer. But from my advantage point, as a cloud solution architect, I'm able to see many customers. I see situations in which instead service-to-service invocation is really the way to go. And so I often agree with the customers that, they have interaction with, for example, an end user, and they have that amount of milliseconds to come up with a result. And if everything is done properly, maybe service-to-service invocation or, pattern, and then the building block of Dapper is the way to go, because it will be easier for you to control the sequence and make it simpler, because if you have to coordinate many microservices, there are many approaches. In my book I described one, there are many others. But there is absolutely place for all of these different patterns.
I like that. So there's a little room for almost a long-term evolution, I suppose, with Dapper, or rather with technologies like Dapper, that you can slowly evolve your. Well, I mean, you wouldn't have to do it slowly. You can rapidly evolve, if you wish, your application stack. I don't just want to say one application, because some people think of a single microservice as an application in itself, whereas I like to think of an application stack, just because that way it's either many things make a whole, or is it all, but that's beside the point. But yeah, I like the idea of the sort of the long-term evolution of the application. You're not having to look at, well, in 6 months we'll need to do a queuing system, so we may as well start looking at it now. Well, actually, no. If like you said, if you're leveraging something like Dapper, you can put that decision off until later on, and effectively, maybe write 100 lines of code, if that, on both ends of your queue, to be able to read from and write to, right? And probably not even that many lines of code. It seems like it makes more sense than the traditional, right, we've got to trash this whole service and rebuild it because now it has to use a queue,
Exactly. This is the scenario that Dapper, that the team that created Dapper saw and wanted to approach with Dapper. So there are 7 building blocks: service-to-service invocation, state management, publish, subscribe. There are the binding, input and output binding. You have observability, you have secrets, and then actors. You can use Dapper and introduce it into your existing application, maybe because you see the value in using one of these building blocks, and then over time, in some portions of your overall solution, you will see the space for replacing the existing approach by introducing another building block. But there is room for, and it's one of the principles of Dapper, to be able to give you the chance to evolve over time and adopt the building blocks you need when you need it. You don't have to use all of these building blocks together since the start.
Sure, it's a little like the new programming features that they bring out with, say, C#8, C#9. You don't have to use asynchronous for each loops or anything like that, right? You don't need to use them. You don't need to use pattern matching, but you can if it fits your project domain, right? If it makes sense to do pattern matching, then use it. If it makes sense to use one of the many building blocks of Dapper, which we've talked a lot about Dapper so far, and we haven't really covered all of the building blocks. But I feel like that's because there's so many of them, right?
yeah. That they are so rich in the features and the scenarios they cover. So yes, I think it will be very challenging to go over it all.
Sure. But I mean, that's why, towards the end of the episode, we'll talk about places where people can go to learn a little bit more about Dapper, right? And at least now they have enough information so that they can go away and they can Google, Bing, whatever search engine they use, they can then go, oh, right, I will look this up and I'll look that up. Oh, cool. This will take me in this direction. This will take me in that direction. So that allows, I guess, people to get a better appreciation of the things that Dapper can do.
Yeah, absolutely.
So I guess, to be fair, we're coming towards the end now. I've only got a couple more questions, if that's all right.
Absolutely. I would love to.
And so one of them is, there's a lot of talk about grpc, right? Because sometimes you don't need all of the overhead of HTTP, right? Does Dapper support grpc? Can I just wire up some services that use grpc and guess what? It just works?
So also there has been evolution in the way grpc is supported in the 1.3 version of Dapper, which just came out. But from the general perspective, so grpc is the way that the sidecar of Dapper communicate one to each other. So let's say you have two microservices. They relate, they invoke the API on the sidecar. Okay, and if you are in a Kubernetes environment, there is a good chance that your code and the sidecar, which will live as container inside of your pod, that these two pod lives on different nodes, probably separated by network. So once your microservices invoke the sidecar, because it wants to use the service-to-service invocation building block to communicate to the other microservice. From that sidecar, the communication to the other sidecar, on the other hand, happens in grpc, even if you use maybe HTTP between your code directly or your code via the SDK. Okay, and on the receiving end, the sidecar, which cooperated via grpc with the other sidecar, it will then communicate with your service via HTTP. This is the default, let's say, default way of using it. But you have the ability also to use grpc on the last mile, let's say, the last leg of the communication between the sidecar and your application and your code. And there are some situations in which getting the benefit of, I would say, reduced latency in grpc compared to HTTP in the last leg could justify the need for using grpc on that part too. From my personal preference, I see a lot of value in interacting between my code and the sidecar, both ways, in HTTP over time. Being for my knowledge and my background, I feel far more comfortable in using plain HTTP REST API, and therefore it's my favorite way of using Dapper. But absolutely, you can leverage gRPC on both ends.
I like that. Like I said earlier, it feels very much like a long-term evolution, right? And as we mentioned previously, just because it's there, you don't have to use it. But should the requirements change, right? Oh, no, now we have to go over gRPC because the project manager has said, or because the customer has said, or because the end client
you have evidence that you need that last advantage.
Sure.
And so whatever you want to gain, that performance gain, well, that is one place. But there are many factors on whether a team prefers gRPC or HTTP. The important part is that Dapr support both.
Sure. So before we talk about where folks can learn more about Dapper, let's talk one more time about the book then. Remind us all what the title of the book is.
Yeah, sure. So it's Practical Microservices with Dapper and .NET. And the idea of the book is really to give you an introduction to Dapper. So you don't need to have an existing starting point on Dapr. This book will give you that. And I describe most of the building blocks by creating with the reader, a project, a solution in C# of e-commerce, very simple e-commerce backend, and so we start with service-to-service invocation. Then we need to keep the information, that state, aside, and therefore we use state management to ease our code from the responsibility of managing the state in your microservices, which could be another talk, another episode. And then builds up on this by using publish and subscribe, the bindings, and obviously observability, which is one of the great advantages of using a runtime like Dapr. And then focus a lot on also the actors, which probably are my favorite building block. And hopefully I didn't name another building block as my favorite before, but it's actors. I'm quite sure.
Yeah, we've discussed a little bit about on a different episode. We interviewed Russell Hammett, and he talked about the actor pattern, and it's a wonderfully elegant way to solve pretty much almost every solution, every single problem I can think of with any kind of scalable architecture. It's wonderful.
Yeah, in fact, I would say I listened to that episode and I realized that I'm looking at the actor building block of Dapr from a different starting point. So, and absolutely it's a virtual actor, but the way I was looking at it, I realized comes from my experience. And to me, the most appealing point of actors is the way that it handles it helps you solve the challenge between consistency and concurrency. And so, while if I remember correctly, the starting point of your conversation was virtual actor is also a way, as you said, to distribute the processing, the compute, on a much larger scale, because the unit of computation will not be just the service, but the specific data set for that instance of the actor and the code. So, but it's I think it's the power of the pattern that speaks to different needs,
Absolutely, absolutely. And, for listeners who haven't heard that episode, I would definitely go back and give it a listen. It is episode 22, so it's very early on in the show's history.
So how much time ago it was?
Oh my goodness. So this, I think, will be episode 82.
Okay.
So quite a while ago. I think maybe 2 years ago.
Well, okay.
But yeah, so maybe we need to do a round table about how great the actor pattern is. And then maybe we can start the great movement away from blockchain and crypto into actor pattern. And then we'll just hear it in all of the the literature surrounding development. Oh, you should use the actor pattern for everything.
Well, that would be with everything in life and in technology. Too much of something is always bad.
Oh, absolutely.
And I come from the wine country of Italy, so you have to be considerate in what is too much of, And so also with actors, it solves some specific challenges, some specific scenarios. And if you face those, absolutely go with actors. But so actors, in a nutshell, they combine your code and data and together, and they distribute this vast population of instances of an actor among all the nodes that you want to use. And so you have a lot of computing, but also you have a very efficient way of managing, accessing, and manipulating the state, because it will be the instance to govern the way that other clients perform action and access the information in the state of the actor. But is not a replacement for state management and the service-to-service invocation. So it's not a super building block. Is the implementation of an excellent implementation of the virtual actor that builds on you can think about all the experience that Microsoft has with Service Fabric and Orleans before it. So everything comes into the actor building block, and as much as I love some services in Azure, it doesn't mean that you have to use it every time. There is a tool for the job, and so it's one of the 7 building blocks, and you have also to use it carefully. Because it's easy to think about virtual actor as a way to distribute your data. Yeah, absolutely. But it is not a database. So probably it's better if you keep away from thinking, well, if the state for read operation is already in memory, which is one of the advantages of virtual actor, well, it will be easy to query it. Then let's compose state from invoking thousands or even more of actor instances and build together and aggregate the information. This is something I would avoid, and probably one of the most common misuse of the virtual actor pattern.
Sure. There are certainly a lot of ways to misuse the patterns and technologies that we have. But I feel like that might be a discussion for another time. I'm just very conscious of the amount of time you have for us today. That's all. That's all.
Thank you very much. But I'm really happy about talking about Dapr.
Mm-hmm.
And as I said at the beginning, I see it really as the solution to most of the challenges I faced, and probably everyone faced in developing distributed application, whether these are with microservices or not, because it's not all microservices in the world. If you build something new, probably it will be microservices, but you can use one Dapr also to improve an existing application and use it to help you decompose your monolith application into microservices. So I see it from this perspective on my past as a developer and how it really solves most of the challenges that enterprise developers face today, also with new applications.
Sure. I do like that, being able to take a potentially a monolith and breaking it down. Mm-hmm. That's a non-trivial task for sure. And if I can use a piece of technology to help me to do that, I will happily do that. Yeah. So where can folks, so let's say a listener is listening along and they're like, I really want to learn more about Dapper. I want to learn more about the book, and I want to learn more about Davide. How do they get in contact with you? How do they learn more about the book? How do they learn more about Dapper? What's your top couple of resources for that?
So you can find me on Twitter at Bedin Davide, and also on LinkedIn. And maybe you can paste the link, in the notes.
Sure.
And so I'm really happy to talk about Dapper, and it's something that is really in my focus today as I'm interested into application innovation. And about Dapper, you can go to Dapr.io, which is the starting point for everything that is Dapper. So my book is the Practical Microservices with Dapper and .NET. Is published by Pat, and you can find it on any online bookstore.
Excellent. Well, all that really remains to say, Davide, is thank you ever so much for spending some time this afternoon. I like I said at the beginning, I fully appreciate you're a very busy man. So I really appreciate you spending some time with us this afternoon to talk to us about Dapper and how great it is.
Thank you very much.
That was my interview with Davide Bedin about Dapr, D-A-P-R, the Distributed Application Runtime, and his new book, Practical Microservices with Dapper and .NET. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered, and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave me a rating or a review on your podcatcher of choice. Head over to .netcore.show/subscribe for ways to do that, or reach out via our contact page, .netcore.show/contact. And to come back next time for more .NET goodness. I'll see you again real soon. See you later, folks.
.NET Core Podcast is a production of RJJ Software Limited.